Hi everyone. In this video, I want to provide an overview of using structs in C++. You can see on my screen here that I've got 4 files open: main.cpp, structs.cpp, structs.h, and makefile. In a recent video, I showed how to create a makefile and use the make build automation tool in order to provide rules about how to build and run this little 3-file format code base I have here. So check out that video if you're interested in learning how to use makefiles. Let me show you what's in these other files so that we can start writing some code related to structs. So main is pretty simple. It includes structs.h, and right now I just have this little hello statement, which I'll take away. We don't need it anymore. In structs.cpp, all I have is a pound include for structs.h. So let's take a look at structs.h. Okay, got some header file guard code, pound include IO stream, using namespace standard, and then the end of my header file guard code. All right, so it's in here that I want to start. I want to take a few notes about what a struct is, and then we're going to define a struct. Then we'll head over to main.cpp, make some variables of our struct type, and then we'll head over to structs.cpp and write some functions that can operate on our struct. All right, so let's start with what a struct is. So there's a lot of different ways to describe structs. This is kind of the one I like the best. Struct is a programmer-defined collection of data members. Okay, I've heard a lot of other names for it. So like it's a programmer-defined type that includes a package of variables, things like this. I think this one is the most clear. Okay, the programmer-defined part means that we, the programmer, get to define our own structs. Okay, our struct that we define is actually a new type, so we can have variables of that type. Okay, and those variables represent memory that have a bunch of different variables, and we call those variables members of the struct. Okay, so in struct's simplest form, they're used to kind of package together data. Okay, so let's take a look at an example. That way it becomes a little bit more concrete. All right, so the example I'm going to do is just a really simple struct to represent a fruit. And by fruit, I do mean like an apple, an orange, a banana, a kiwi, etc. All right, so structs are defined in header files. And I want to note that no memory is allocated for a definition. Okay, we're just defining the struct type. We're not actually creating any structs in memory. Okay, we're going to do that in main.cpp and or in structs.cpp. In the header file, you just put the definition for a struct, okay, that defines this new type you're creating. All right, so we'll use the keyword struct, and then the name of our struct, we'll call it fruit. Okay, this is also known as the tag. Curly brackets in order to group together this collection of data members or this package of variable types. Don't forget your semicolon on the end here. Very easy to forget. And in here, I'm going to have a string to represent the type of fruit, like apple, banana, orange, etc. I'm also going to have a string to represent the color, like red, green, yellow, orange, etc. And for fun, I'll add in one more data member to my struct. I'll call it weight. Okay, so this will be like a weight in ounces, like how heavy is the fruit. Okay, obviously I could have chosen, some other real-world object to represent via a struct. I could have added more or less data members to my fruit. Like I might have one like bool. Does it have, seeds on the outside? Is it a berry, etc.? I could have added a bunch more, but we'll just stick with these 3. Okay, so this is the complete definition for my struct of called fruit. Okay, no memory is allocated. Okay, I'm in a header file. I'm just defining a new type called fruit. A fruit consists of 3 data members, a type, a color, and a weight. So now let's head over to main.cpp, and we're going to start making some variables of type fruit. All right, so I'm going to have a fruit called my fruit. And here's just the declaration for my fruit. Okay, right now it has some kind of garbage values for its members. Okay, I can also initialize it so that it has values that I provide for its data members. So let's say I want my fruit to represent kiwi for its type, which is brown, and maybe weighs about 2.5 ounces. All right, so you're probably thinking, okay, what are some things we can do with structs? Well, you would think that we would be able to just print out my fruit and see kiwi brown 2.5. But when I go to compile this, okay, I actually get tons and tons of errors. So many errors. Look at all of these. Okay, if I scroll all the way up, I'm going to see error, no match for operator. Okay, this is our stream insertion operator. Operand types are OStream, okay, that's my cout, and fruit. So it's complaining and saying, okay, this operator isn't defined for one of its operands being a fruit. The compiler's never seen a fruit before, right? There's no definition for this operator to operate on fruits. Okay, so in another video, or if you want to take a look online, do some Googling, if you want to be able to print out your fruit object or your fruit variable here, you would actually need to provide a function that performs operator overloading in order to define how do you print out or how do you insert into a stream a fruit variable. All right, so we're not going to do that in this video. I'm going to just comment it out, and I'm going to take some notes and say I can't use the stream insertion operator and fruit until we overload the stream insertion operator to work with fruits. Okay, so we won't do that in this video. What we can do is we can access individual members using the dot operator. Okay, so the dot operator is called the direct member or the direct component selection operator. Okay, it allows you to select the value of a member from a variable of type struct. So let's say I want to cout myFruit.type. Okay, so myFruit is of type fruit. Type is a member of the struct fruit. So I can actually go to myFruit in memory and select its type value. Okay, so now we should see kiwi when we compile and run this. And we do. All right, so now that we know we can select individual member values from a struct, let's do this, and let's define a function that accepts a fruit and prints out with labels, because labels are always helpful, the values of all the fruit members. Okay, so here's what a call to this function would look like. Maybe something like print fruit, passing in my fruit. So anytime I want to do something like this, but I don't want to go overload the stream insertion operator, I can just call my print fruit function. All right, so let's provide a prototype. Okay, it would be good practice to throw a const on here because print fruit is not going to modify the fruit, it's going to just read it only. In structs.cpp, this is where I'm going to put my definition for print fruit, and I'll just call that parameter there f. All right, so I'm just going to put labels on all the different member values I'm going to print out from f. All right, so let's compile this and run it. And here we see the output from print fruit, right? I'm passing in my fruit, which I initialized to kiwi brown 2.5, and now I have this nice little utility function I can use anytime I want to see what one of my fruit variables looks like in memory. All right. So now that I have this, I want to show you one thing. If I didn't actually initialize my fruit to kiwi brown 2.5, let's take a look at what our output would be. Okay, we get empty strings for type and for color, and then we get this garbage value for weight. So I want to emphasize that just like other memory, like integers or chars or whatnot, when you allocate memory on the stack or the heap, you're not guaranteed that it's all zeroed out. Okay, so you want to make sure that when you're working with structs, and especially when you start working with, say, arrays of structs, that you go through and you initialize those structs to have good default values before you start to work with them. All right, next, let's do pointers to structs. These are kind of fun, right? So I might have a fruit pointer. I'll call it my fruit pointer. And I'm going to assign it the address of my fruit. So now I can see out the contents of what my fruit pointer points to, which is my fruit, and select its type. Okay, this seems like it should work, right? If I dereference my fruit pointer, then I'm going to be at my fruit in memory, and just like we did on line 12, I should be able to select my fruit's type, which is kiwi. Okay, I'll save the file, I'll run make, and unfortunately it doesn't work. Okay, it's saying error, request for member type in my fruit pointer, which is of pointer type fruit, fruit pointer, okay? So why doesn't this compile? This doesn't compile because this dot operator, the direct member selection operator, has higher precedence than the dereference operator. So we want this to occur first, dereference, then select. But what actually happens first is select. And a fruit pointer doesn't have a type member because it's not a struct. It's a pointer. So what we actually have to do is add parentheses in order to force the dereference to happen first. Okay, now I can compile and run this, and I see kiwi, which I'm accessing indirectly via my fruit pointer, whereas up here, I was accessing it directly using my fruit. All right, now this is kind of clunky syntax because we need to do this dereference and select quite often. So if you saw up here in this compiler error, it says, maybe you meant to use the arrow operator. Okay, so what's the arrow operator? So the arrow operator looks like this, and its fancy name is the indirect member or component selection operator. Okay, so it's very similar to the dot in that it selects something from a struct, but what it does first is dereference a pointer to the struct. Okay, so I can type that here. Dereference the pointer and select from the struct it points to. Okay, so it does both of those things. It's a really great operator. So let me write line 18 again, but this time I'm going to use the arrow operator. Okay, we'll see, it does the exact same thing, but I actually get much cleaner syntax. Okay, so there I'm printing kiwi twice. Two different ways to do it that do the exact same thing. So line 18 and line 23 do the exact same thing. All right, I have a few more things I want to say about structs. Okay, so one thing is structs are passed by value. Okay, so in our example up here with, where to go, print fruit, okay, the value of each member in my fruit is copied in to F, okay, right here. They are not passed by reference or passed by pointer, okay, they are passed by value. All right, next, struct assignment is okay. It makes a copy. And that should make sense now that we know that structs are passed by value. So if I wanted to, I could have another fruit variable called my other fruit, and I could assign it my fruit. Okay, this makes a copy. So let's say my other fruit, its type isn't a kiwi. Let's say it's an apple. So now if I print out my fruit and I print out my other fruit, I should see that they have different values because they are not pointing to the same memory. They are, in fact, two different fruits in memory. So here's the kiwi, brown 2.5. Here's the apple, brown 2.5. And I could change the color to red and say the weight to like 3.1 or something if I wanted to. These are two different regions of memory. All right, next, how do we compare fruits? Let's say I have an array of fruits. I'll call them my fruit array. Let's say I have 10 of them. Let's say I fill them up with some valid data, and then I want to sort my fruit array. Okay, how would I do that? Well, if this was an array of integers or an array of strings, we would probably call upon relational operators, like especially the less than sign, maybe the greater than sign. Other relational operators include the equality operator, the inequality operator, less than or equal to, greater than or equal to, etc. Okay, so this fruit type, right? This is programmer defined. The fruit type didn't exist in C++ until I defined it. So these relational operators aren't actually defined for fruits, okay? It kind of brings us back to the same problem we had up here, right? When I said we can't use the stream insertion operator in fruit until we overload the stream insertion operator to work with fruits. So the same thing down here. I can't actually use these operators on fruits unless I overload them to work with fruits, okay? So we can still get around this by kind of doing that little trick. It's not really a trick, okay? That little workaround I showed earlier where, okay, let's just define a function that prints out a fruit then, right? So we could define a function that takes two fruits and returns, let's say, -1 or a negative number if the first fruit is less than the second fruit. Okay, 1 if the second fruit is greater than, or actually this would be less than, if the second fruit is less than the first fruit. I could have written this alternatively saying 1 if the first fruit is greater than the second fruit, or 0 if the fruits store the same values for their members. Okay, so if you're familiar with, say, C, this would be like the string compare, strcmp function in the C string library, or if you're familiar with Java, this would be like writing a compare to, right? We need this information in order to order two fruits as part of, say, a sorting or an ordering algorithm. Okay, so we can write this function. That way we can order fruits and compare them. We can also use this function to test for equality. If this function ever returns 0, then these two fruits store the same information. Okay, so let's write this function. I'll just see out its return value. I'll call it compare fruits, and I'm going to pass in my fruit and my other fruit. Okay, now we know that these store different values. So this function shouldn't return 0 because my fruit stores kiwi as its type, and my other fruit stores apple as its type. Okay, so between these three values and these three values, which one should come first? Well, if we're ordering by type first, then alphabetically, apple should come first. So that would mean the second fruit is less than the first fruit, and this function should return 1. If they were both kiwi, and they were both brown, but let's say this one's weight was 2.1 and this one was 2.5, then the function should return -1 because the first fruit is less than the second fruit, right? We compare first by type, then by color, then by weight. Then if we have the same type, same color, but a smaller weight in the first one, then the first one should come before the second one. All right, so let's head over to structs.h. Our prototype is going to have int as its return type, compare fruits, and just for fun, let's have this actually work with two fruit pointers, right? We already wrote one example using a fruit. Let's do a fruit pointer. So I'm going to change this to have address of. It'll just give us a little bit more practice with that indirect member selection operator. So I'll call my first fruit pointer F1 and my second one F2. Just make sure you remember that these are pointers to fruits. They are not fruits themselves. All right, so let's compare first by type. We'll go by type, then color, then weight. So this is going to be a member-wise comparison. So F1, if I grab its type, okay, so dereference and select, that's going to be a string. If this string is less than F2's type, okay, then I know I should return -1 because the first fruit should come before the second fruit. Okay, if this isn't true, then perhaps F1's type is greater than F2's type. If this is the case, then I know that F2 should come before F1, or said alternatively, that F1 should come after F2. So I'm going to return +1. If I make it to this else, then what do I know? I know these two fruits, or these two fruit pointers, point to memory that has the same type. So I need to then check the color to see if I need to sort by color. All right, so it's kind of a rinse and repeat. I'm going to do the same thing for color. So the interesting part is if I get here, okay, to this else, what do I know? I know they have the same type and they have the same color. So I should then start checking the weight. You can see that this is starting to be quite the long nested function here. Of course, you could write this in a cleaner way, but this is probably the most verbose way to write it. All right, so if F1's weight is less than F2's weight, then I know I should return -1. On the contrary, if F1's weight is greater than F2, then I should return +1. Okay, here's our last case here. If I get to this else, I know that these two fruits have the same type and color and weight. So essentially, all of the values of their members are the same. What do? I return 0. So let's run this. Okay, and I see 1. Okay, so how do you interpret this 1? So the left operand was a pointer to this fruit, and the right operand, or I shouldn't say operand, the first parameter was a pointer to this fruit, and the second parameter here is a pointer to this fruit. Okay, so if I see 1, then I know that if I were to sort these two, then the second one should come before the first one. Okay. So I'm going to copy this, and I'm going to actually change back my other fruit type to be kiwi. So you can see that it's going to return 0, letting me know that these are in fact two fruits that have the same values member by member. And there's that 0. So in addition to writing a function that could be used to sort fruits, I also just wrote a function that could be used to test two fruits for equality or inequality. If I ever get something back other than 0, I know these two fruits are different, member by member. All right, I think this is really close to the end of the video. I showed you up here how to statically allocate 10 fruits contiguously in memory. Okay, I've got an array of 10 fruits here. The syntax for dynamically allocating an array of fruits is really no different than dynamically allocating an array to store some other type like integers. But for fun, I'll go ahead and do it. So I'll do like my dynamic fruit array. Okay, so I have an array. Maybe this one has 20 fruits in it. Okay, and I'll just make a little note here. Be sure to zero out memory. Be sure to free this memory when you're done. All right, well, that wraps up my crash course on how to work with structs in C++. Thank you for watching.